Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to our first lesson in a new unit on rational expressions and rational functions. Today, we will learn to define rational expressions and identify the universal set of a given rational expression. We will also learn the four fundamental operations of rational expressions and decompose them into sums of partial fractions. If you are ready, students, we will get started. A rational expression is the quotient of two polynomials, p of x over q of x, where q of x is not 0. P of x is called the numerator, and q of x is called the denominator. For our first activity, observe these four functions, which are rational expressions. Take a moment to decide.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Looking at these four functions, we must identify which ones are the quotients of two polynomials. Expressions a, b, and d are rational expressions, but expression c is not. This is because the square root of x is not a polynomial. If we wish to find the domain of a rational expression, we must set the denominator of the expression equal to 0 and solve. The domain is the set of all real numbers except those numbers which we find by doing this. For example, look at the rational expression 9 over 2x. If we set the denominator to 0, then x equals 0. Thus, the domain of x is the set of real numbers except 0. If the numerator and denominator do not have any common factor other than 1, we say that the rational expression is reduced to lowest terms, or in simplest form. To simplify a rational expression, we must first find the domain. Then we factorize the numerator and denominator completely. Finally, we divide the numerator and denominator by any common factor, canceling like terms. Try this for yourselves, students. Try reducing this rational expression to its simplest form. You may get started right away.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, everyone. First, we reduce the denominator to 0 to determine the domain. When x equals -4, the denominator is 0. Therefore, the domain of x is the set of real numbers when x does not equal -4. Next, we factorize both the numerator and denominator completely. The expression becomes x minus 2 times x plus 4 over 2 times x plus 4. Now we can cancel like terms. X plus 4 cancels out, leaving x minus 2 over 2. Therefore, x minus 2 over 2, for all x an element of the set of real numbers without the set containing -4. Great job. Now let us learn to perform the 4 fundamental operations on rational expressions. Note that rational expressions obey the same rules as rational numbers for addition, subtraction, multiplication, and division. Let P of x, Q of x, and R of x be polynomials, such that Q of x does not equal 0, and S of x does not equal 0. In the case of addition, P of x over Q of x plus R of x over S of x equals P of x times S of x plus Q of x times R of x over Q of x times S of x. In the case of subtraction, P of x over Q of x minus R of x over S of x equals P of x times S of x minus Q of x times R of x over Q of x times S of x. The multiplication of rational expressions is equally straightforward. Let P of x, Q of x, R of x, and S of x be polynomials such that Q of x and S of x do not equal 0. Then P of x over Q of x times R of x over S of x equals the product of P of x and R of x over the product of Q of x and S of x. To multiply rational expressions, factorize the numerators and denominators completely. Then divide out the common factors. Finally, multiply the numerators with each other and the denominators with each other to find the answer. In the case of division, let P of x, Q of x, R of x, and S of x be polynomials such that R of x, Q of x, and S of x do not equal 0. Then we flip the divisor and multiply. The result is the product of P of x and S of x over the product of Q of x and R of x. Now we will do an activity to help us remember how to add, subtract, and multiply rational expressions. For each of these rational expressions, state the universal set, then simplify them. You can get started right away.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Have you finished, students? Let us check our answers together. The first operation is simple because both terms have the same denominator. 2x minus 3 minus 3x minus 5 equals negative x plus 2 is 2x plus 1 over x squared times x plus 1, for x cannot equal negative 1 or 0. The third operation is a little bit challenging. we must begin by factorizing both terms. So the expression becomes x minus 3 times x minus 4 over 4 minus x times 5 over x minus 3 times x plus 3. Then we cancel common factors on both numerator and denominator. X minus 4 and x minus 3 cancel out. We can multiply the terms and find our answer, which is negative 5 over x plus 3. For x cannot equal negative 3, 3, or 4. I hope you found the same answers, students. That is all for today. We have learned about rational expressions. We have studied their simplified forms, the fundamental operations, and how to convert them to partial fraction form. Teacher is going to discuss the division of rational expressions further, and will also explain the decomposition of rational functions. Until next time, thank you, teacher. Thank you, students.